Okay, so this problem involves forces, moments, rotations, 4 revolutions in fact, and it wants us to find angular velocities after these rotations. So this is definitely an energy problem. It involves distances and angles and forces and velocities. Normally I would do this all about the center of gravity, but it's getting late. I'm running out of steam, and so it's more convenient to do this around O because everything's spinning around O, and that's how I'm going to solve it. So if you're going to solve this problem spinning around O, you need to know the moment of inertia of the bar around O. And the parallel axis theorem is you take the moment of inertia about its middle plus m times d squared. So it's a slender rod, 1/12 mass times length squared, plus the mass times the distance from the center of gravity to the pivot point, which happens to be 0.5 meters squared. So that's the moment of inertia about the middle. Okay, and so now the work energy problem is you have the initial kinetic energy. There's no 1/2 mv squared because I'm being lazy, so I'm doing rotation about the pivot point, and it's all taken into account because I have the moment of inertia about the pivot point. But anyway, it starts from rest, so there's no 1/2 I omega squared. And so afterwards, again, there's no 1/2 mv squared because it's all taken into account that I've got it about the point O, 1/2 I omega squared. And that's what we're going to try and figure out, what's the omega afterwards. Okay, so the work, the angular work about that middle, it's similar to force times distance. It's moment times angle. And so the total work done is the total moment times the angle, and it's 4 revolutions. You need to change that to radians, 2 pi per revolution, so 8 pi. Okay, so the moment about O, the total moment, there's this 20 Newton meters times a distance of 1.5. There's the 30 times the distance of 0.5. And then there's this 20 Newton meter moment just applied right at O. So there's those 3 things. Those all add up to 70. And so the integral of 70 from 0 to 8 pi, so it's 70 times 8 pi, equals 1/2 I omega squared, and you can solve for omega 2. Now, there is no mgh in this problem because before it starts here, and after 8 complete revolutions, it ends horizontal as well, so the mgh is the same before and after, it's 0. So this is the solution to the problem.